Greetings, welcome. This video then is for a commenter commented on the penny roll 3 video that you should have an ammeter in place. And while I was eyeballing things on the power supply, he's got a very good point. And so I shelled out for yet another $10 multimeter. And so we'll use this to look at the amp draw. The key though is you can't connect this thing when it's just starting up, or it's going to blow the fuse. You got to get it spinning and then put your digital ammeter in place. And I'll kind of show you what I mean there. So we'll be running at 4 volts. I've got the code about where I want it. And so 28, so 280 milliamps, and you're on a 200 milliamps scale, and it's a pulse and it keeps happening. And so boom. And I can also feel with my fingers here. Right there it is, right there. So we know we're in attraction mode. So I'll spin this up, and then we're going to do the same thing as last time, except we're just going to put all the pennies in one kaboom. And so we gather the baseline first with the load disconnected, only the ferrite core. They are just to make sure that nothing kind of rattled and moved to over here, over to there. That this thing is taped in as best as I can do it to make sure that the sensor doesn't move, the coils don't move, and we start off with it empty, except for, as I said a couple videos ago, one of those pennies is wedged in, so I got to do the baseline with one extra penny. And aside from that, we're ready to go. So I'm going to spin it up, and then I'll connect the ammeter and get back to you. This has been spinning for a little bit and settled in around 707.5 RPMs. And our ammeter, because it's getting the pulses, is going between 28.2 and 28.7. 28 point, there I saw it, so we'll call it 28.5. And that lines up with the 30 on the much rougher precision power supply. I can't remember what I said, but I'm going to put it in the spreadsheet after I check again. So we just jotted that down, 707.5 RPMs, 28.5 milliamp draw. Now for the rest of the baseline, we'll short the pickup coil to give it a lot more resistance. Now we've let it spin under load. We are at 470.8. Our milliamp draw is what? It's bouncing around is what? Between 40.7 41.2, I would say probably 40.9. So we jot that down, and again we have our baseline unloaded and under load. So now first shut this off to not fry the meter, disconnect this, turn this off, stop this. Without moving anything on there now, I'm going to put 8 copper pennies in each of those slots. So we have our jar of feather pennies, and I'll put those in. So we're adding weight. It should spin slower and draw more power, right? That's what you would think. I'll get back to you when this is loaded with pennies. Okay, so once again we have the pennies in, and we'll be at 4 volts again. I'm going to spin this up. We'll do the underload one first, since that's already hooked up, and then we'll disconnect that and spin it up without the ammeter connected first, and we'll compare the two. So we've added the pennies, spun it up, we're still under load. This is what we saw without the added mass, 470.8 and 40.9. We've just a little bit more than doubled the mass of the rotor, and we are spinning at 553. Yeah. It might still be climbing a little bit, but that's what I'm going to say is 553. Now, what is the amp draw? It was 40.9 previously, and now it is that. What is that? 36.9, 37.4. We'll call it 37.2. 37.2. So that's sort of the more important part, because that's with the rotor under load. I'm going to disconnect the load now, and we'll see how it compares there with the nearly unloaded condition. And so the last thing is, yeah, it goes faster with the extra weight. And why did the milliamp draw go down? Should I leave that for homework? I'll just tell you. It's that as it's spinning faster, the pulses are becoming briefer and briefer. And you know with an inductor that the reactive resistance is greatest at the start, and then as the coil goes towards its saturation value, all you have left is the straight line DC resistance of the wire. So as the pulses are becoming quicker, it's hitting more of the very high resistance reactance. And so you're drawing less power and you're spinning faster under load. So now we look at the unloaded. There's our baseline, 707.5, 28.5, and 846. I might still be climbing a little bit, but 846 sounds about right. What is our amp draw? It is between 23.9, 24, let's call it 24. So again, we see the amp draw has decreased. Now, to be entirely honest, I haven't touched anything there, but the meter may be drifting up, wanting to drift up a 20th of a volt. But even if so, and it's 4.05 times 24 instead of 4.0 times 28.5, you're still drawing less power and you're going faster. So last thing, it may not work out, just to try to live dangerously. I got 8 pennies. I don't know, what do you think? I think we might be able to fit a 9th, and this rotor is good enough that we just might get away with it. Or maybe I just want to see pennies go flying around the room. I'm going to try that, and let's see what happens. All right, I've added one more penny. This may end badly, but I'm going to give it a go. And if I'm right, we'll see the trend continue, and it'll spin just a tiny bit faster than previously, or at least not slower. Okay, this thing's actually held together. It wasn't a disaster. I just need to not bump anything. So we're looking at that, 843.6, 24 milliamps, and we added a 9th penny to each slot. I'm going to go with 905.2. It might still be climbing a tiny bit. Our amp draw without bumping the machine, between 22 and 22.3. Now there's a little lower. Let's call it 22.1. Alright, let me shut this down because it's surprising that it was balanced enough that those pennies did not decide to fly off. Do we try another? No, we do not. All right. That's actually a little bit more than I was expecting. I would have expected like 870. There may be something. Copper was not the best choice for adding mass because it's diamagnetic, as someone pointed out to me. So the early ones down here, you might be getting some diamagnetic resistance even that's outweighed by the extra mass. Okay, well that's it. This was the first time I did this with this digital ammeter. I knew we were going to see that. I knew that this was what we were going to see, and now we've documented it, and we even have a third data point showing a trend. So keep smiling. Talk to you later. Bye-bye.